Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this specific video we will be focusing on model evaluation part where we will specifically see that okay, now we have learned so many models in machine learning. We have started our journey in this course with linear regression, and somehow we approach towards ensemble techniques where we have explored that how with the help of multiple models working together simultaneously give us some task in bagging, then followed by boosting where combining all the weak learners to get a strengthened final outcome. At the end we have talked about stacking, so where we have seen that we can combine different machine learning algorithms also and harness the power of all those algorithms to get the final outcome. So far so good, but let's assume that I'm working with one data set and I'm not sure that which specific algorithm will works the best in that specific scenario. So yes, we can make a better judgment by doing the analysis of that data in a EDA step, by looking into that how the data set looks like, is that holds a linear relationship or non-linear relationship. That's completely fine, right? That things we have already learned with respect to each and every algorithms. What are the assumptions? What are the things that we need to take care of when we are trying to model our data with linear regression or SVM or SVC or random forest or decision tree and so on, right? But the main point is that if let's say I'm confused with let's say two or three models, I'm not sure that which specific algorithm will works the best. In that case, the good idea would be that let's try to curate a complete pipeline of those algorithms where you feel that they might fits the best, and let's try to do the comparison between those classifiers. Maybe in one go you can apply random forest also, XGBoost also, you can apply gradient boosting also, whatever you feel might suits the best with respect to that specific algorithm or that specific data set which you're working with in a healthcare domain, in a fintech domain, whatever domain you're working in. So today is one of the most interesting session with respect to that part where let's say I'm working with some data set. I'll showcase you with the help of healthcare data where we will take a open source data of breast cancer, and what we will do is we will try to see that how can we curate a complete pipeline where we can try to train our model with multiple models. Till so far in our course, I have not done this task. The flow was like I was trying to explain you the mathematical intuition of one algorithm. Then we have checked the implementation for the same. But now what I'm trying to convey here is that let's try to see that how can we implement maybe two, three, four models wherever we feel that okay, these models can works the best on this data, and then maybe we can try to compare the performance of each and every model, and whichsoever you can say model works the best, that is something which we can say as a final result. So without wasting any time, let's try to deep dive into the implementation part. One thing you have to make sure, now in this video I'm completely skipping any mathematical intuition of algorithms because I already delivered that. It's a module of specialized machine learning techniques where the main focus is to see that okay, whatever things we have learned so far, how can we realize that knowledge in order to make the best out of this, right? In case of industry relevant projects also, you will do this practice where you will try to apply multiple algorithms, compare the performance, showcase the performance to the clients, and then you can have one proof, right? Why you're working with random forest in this specific case, or why you're working with XGBoost in this case, why you're working with logistic regression in this case. So you will try to compare the model evaluation part, maybe precision, recall, accuracy, depending upon what kind of data set you're dealing with. And then you can say that okay, in this case because these numbers are good, that's why I'm working and going ahead with a maybe random forest algorithm. So that is how basically the things will work. So now without wasting any time, let's get started. So now what I'll do here is just for the demonstration purpose, because I just want to showcase you that how the complete pipeline works and how can we curate multiple machine learning models in one go. So what I'll do here is I will try to pick up first of all the frameworks which are required to import that specific data set. One more thing, here I'm using open source data. You can definitely replace with respect to whatever work you are doing in the dataset part. Uh, Another important thing that I'll not do EDA here. I'll not showcase your mathematical intuition behind the algorithm. So please make sure, if you are someone who is not aware about those facts, you have to watch my previous videos before jumping towards this video. Everything is in a sequence. So please make sure that you are taking this knowledge with respect to the sequential manner, which I have showcased you in the course part. Okay. So let's try to first of all do the very first step, that is to import all the required frameworks, okay, and let's import that. So what we can do, we can say import pandas as pd is the framework, import numpy as np is the framework. Afterwards we have matplotlib, we have seaborn. Apart from this, as I told you, we will be working with the different data sets. Maybe let's take for now one single data set of breast cancer and different machine learning models. So we need to import that as well. So maybe let's implement random forest classifier. One more thing I'll do here is I'll change the runtime type to GPU, so that if even though it will take more time, it won't be an issue for us, because I'm doing a recording for this session. So I don't want it will take more time to get the training done. But let's see how will it work. If it will take more time, maybe I'll have to pause the video in between. So let's see how the things will work. So we will try to take from sklearn dot ensemble. I'll import random forest classifier. Yes, we are dealing with a classification problem for now. After that, maybe train test that is required, accuracy score is required. Apart from this, I will try to take few more models. Maybe we can implement neighbors, k neighbors classifier, import k neighbors classifier. Confusion matrix classification report is fine. Standard scalar is also required, it is fine. Apart from this, any other model which I can think of, maybe we can take logistic regression if you want. It's a part of linear underscore model, and here we can just import the logistic regression model. Apart from this, any other model, let's try to keep it for now 3 models, or maybe let's take 4 models. Another one is svc. I'll take, I can see this from sklearn dot svm. Let's import svc. I think for now these many models are fine. If you want to add few more models, definitely you can add it. Okay, so let's try to run this part, and once this is done, let's try to now second part, load the data. So for now I'm working with a breast cancer data set, and it's a classification problem where the result could be either 0 or 1. So what we can do is data is equals to, definitely we need to load it. So it's an open source, as I told you, load underscore breast underscore cancer. I think to load this part, we need to take it from sklearn. Then only it will be able to load from sklearn dot datasets. This is the part where all the datasets are available. We need to import load breast cancer, and I think now it will be loaded perfectly fine. If you want, I can showcase you the data. We can print the data and we can see how will it looks like. So here you can see very clearly that this data is composed of one array specific data points, which is obviously the records that we have, and after that we will be having a target value which is available, which is composed of the values as zeros and ones. Definitely 0 indicates, you can see, right, the target is two names, malignant and benign. You can just if you want, you can do a research. These two I feel are the cells, whether it is available or not. So I think 0 indicates that a patient is of malignant. Let me just copy and showcase you. I think we will get a better idea with respect to data, because I'm also not a doctor. So it's better to take knowledge of that. So you can see a benign tumor has distinct, smooth, regular borders. Malignant tumor has irregular borders and grows faster than benign tumor. So both of them are tumor somehow, but I think one indicates that a person belongs to benign and 0 indicates that it doesn't belongs to. So refers to the presence of cancerous cells that have the ability to spread to other sites in the body or to invade nearby and destroy the tissues. So you can just explore more about this part, that is this good or bad, and if the target is having malignant, what is that indication all about, what is the meaning of banning. Although I have showcased you few bits of taking it from Wikipedia, right? So I think till so far things are clear, that we have features, and at the end of the day we have in the target column cells available, and we need to give the prediction whether it is 0 or 1 as a target value, right? So definitely we have to split our data into input features and the target variable, right? That's the next step, where after loading the data, we will try to do the data split, where we will do the splitting of given data into input features and target variable. Once we do so, so what we will be having is the x as the input feature, which is data dot, sorry, this is not required. X is equals to data dot, you can say data, and y is equals to data dot target. And once we finish this, if you want to print the value of x and y, we can clearly print that. So here you can see we have input features available very clearly for x part, and we have target values in the form of zeros and ones which are available. Now, after doing this part, as the third step, what we have to do is we need to somehow do the data normalization, because we are somehow using here specifically SVC and KNN algorithm. And if you remember, those specific models requires very well the data to be of equal scale, otherwise they won't be able to tackle very carefully, and it will be able to give us vague results. Although I am not doing complete end-to-end EDA, which we usually do, which I have showcased you in the initial part of the sessions in this ML course, but data normalization is something which is important, and that's why I'm doing here. So for that, I'm using standard scalar, which basically converts the data into standard normal form, and this basically scales our data in the form of zeros and ones. So let's try to do that. So for that, what we can do from sklearn dot pre-processing, what we can do is we can just import standard scalar. After that, we can just apply fit underscore transform on the value of x part, right? So if you will see, once we will print the value of x, now what is happening is the entire data we have transformed it, I would say scaled it, right? Once it is done, what we can do is we can just simply try to split our data into training and testing. Usually the correct approach could be where you can first of all do the data splitting and then apply fit underscore transform on the train set, and just transform on the test set. But for now I have done the complete standardization altogether for the x input features altogether, and then I am doing a data splitting. But that's the better approach which I just now have showcased, and I think in the previous sessions I have showcased you also data splitting into, I would say, train set and test set. So how can we do so? We can simply say, so here we can just do simply one thing. We can say x train, sorry, x test, y test, train test split. And here we will be having the value of x, which is a scaled value, the value of y, that is fine. Now, once it is done, we can simply do one more thing. So that's what I was talking about. That's the perfect way actually. So maybe let's do one thing. Let's try to do the data normalization over here. Or you can say, yeah, data normalization we can say over here, where we can just try to apply the standard scalar and using the fit underscore transform on the train set and transform on the test set. So what I'll do is, for that part, I have to restart the session and run everything again, so that things will not get impacted and we have the exact value of x. Then first of all, we are doing a splitting. Now it's a correct approach to do that. Now we have the scaled value of train and test. And finally, once it is done, we can just go directly towards the data modeling phase, where we can apply a pipeline of multiple models in one go. So we have models, which is equals to, it's a part of a dictionary where we can apply maybe random forest algorithm. And for that specific algorithm, what is the classifier? This is the method name, right? After that, maybe we can apply logistic regression or KNN. Logistic regression is also fine. After that, we can apply SVM, SVC will be there. So what is happening is we have applied all the kind of classifiers, whatever we want to apply in case of this model. Now, if let's say you want to extend it and if you want to add few more values in one go, a few more functions you want to apply, definitely you can apply that, but please make sure as per that thing, complexity will increase. Now, what we can do is we can simply train our models, and it will take completely models.items, fit your data into train part, and once it is done, it will just print the result as the training is successful. So this is what we have done. One thing, because there are the parameters which are available and we are taking it as a default one. In the SVC, I want the probability values to be true, because for every classifier, I want the probabilities also for the class belonging to 0 and 1. So I'm making it as true. So here, if you can see the SVC classifier documentation, if I'll just open that. Although we have discussed everything in our previous sessions with respect to SVC also, I'm so sorry. So let's try to close this. And here, you can see by default the probability is false. But what I want is for every classifier, what is the probability I want to showcase to you? That's why I have made it true. Okay. So let's wait for a while and let's try to train this model. And amazingly, it has done perfectly fine. Now, what I want is, I just want to see the results with respect to every classifier. So here I'm not, using any as such hyperparameter tuning. I'm directly trying to store the results. So here you can see results is a dictionary to evaluate that. And what we are doing here is we are applying one for loop, which will try to iterate with respect to the models part, in which we will be having specifically 4 models available. It will try to give the predictions. And that's what I was talking about. I also want the probabilities of those model. That's why I'm using this predict underscore proba value. It will give me the probabilities. Now this is fine. Here I just want the probability of one class. So I have just used the column number 1. After that, this is the accuracy, precision, recall, F1 score, ROC, AUC curve. To evaluate that, definitely from sklearn, we need to import from metrics, whatever be the classifiers we want as a result. So we want precision score, accuracy score, recall score, F1 score, ROC, AUC score. Okay? So I think that makes sense now. So it is saying if that model is having an attribute of predict underscore proba, give me the probability. Otherwise, print the answer as none. So it will just take care of that error as well. And same thing will happen over here. So now let's try to display the results and let's see how the results looks like. So here in one go, now you can see very clearly that we will be able to get the result of how random forest is working on this specific data set, how KNN is working, how logistic regression is working, and how the SVM is working. Somehow you can see that accuracy is better in case of SVM. Even I can see precision, recall, F1 and ROC, AUC. Somehow all of these metrics values are better. So it might be the case, even though we have not done EDA task in an appropriate manner, if we do that, that will be the right correct answer, I would say. But definitely depending upon whatever things we have performed here, yes, we can say that SVM is the algorithm which is working far better than other algorithms that we have. In the second case, it will be random forest. In the third one, the ranking should be logistic regression. And at the very end, it will be KNN. So that is how basically we can compare the models and we can just print this results underscore df to get the final outcome. So this is how basically we will be able to compare the results. So for the model comparison per se, you can simply print this results underscore df. And if let's say you are showcasing to the client and you are applying in that specific data set, maybe SVM algorithm you are choosing at a final answer, or random forest, because both of them are comparable, having a similar kind of a result. So you should have a solid reason for the same, apart from the assumptions, apart from the hypothesis that you are making, what is the number which you are getting when you're working with the same data with respect to random forest and with respect to SVM. And if you will showcase you this kind of a stuff to them, that gives the interpretability of the model, that gives more explainability of the model, that okay, that's why we are relying on this specific model and not on the other model part. So I hope that this makes you a sense now that how basically in real time scenarios the model selection will be done, and how basically we can compare depending upon what kind of data we are working with respect to the different kind of algorithms that we have in machine learning. So now I hope that you get the clear cut picture of how basically we can apply multiple machine learning algorithms in one go, and we can implement that. It's just that we need to define whatever algorithms you want to implement in the dictionary, and then we can just have to run a loop, and it might take some time. If you want to do hyperparameter tuning on top of that, you can do that very wisely. We have already seen that how basically we can do hyperparameter tuning in the previous session, so I'll not discuss that part. But all in all, this is one of the technique where we can clearly compare the results with respect to each and every algorithm, and we can get the idea that which specific model will works the best with respect to a given data that we are dealing with. So with this, let's end today's video. I will see you all in the upcoming video where we will discuss another amazing concepts with respect to machine learning. I hope you are enjoying till so far. Please do share your feedback as well, how the learning journey is going on. We are about to finish our interesting ML course, and I feel super excited that whatever knowledge I have shared till so far, it is pretty much clear to everyone. With this, bye bye everyone, and I'll see you all very soon.